Hello everyone, let's look at the solutions of the week number 73, and we will look at the Raku solutions. And the first task is called mean sliding window. You are given an array of integers a and sliding window size $s. Write a script to create an array of min from each sliding window. An example, so here's the data. Sliding window width is 3. And the output is, so basically, so we're taking these 3, the minimum is 0. We are moving one item right, and here is another set of 3 elements, the minimum is 0, and blah, blah, and so on. When we move on further, and the minimum is 3. Okay, so it's extremely clear what we have to do. So let's look at the solutions. In the Raku programming language, let's go from the end of the list. So Raku 1, Ulrich, and it is here. Okay, so we are taking integer w. What is w? I believe this is width. Enter array, the array. So yeah, we have to, so we're prompting something, and while we didn't type end, we're incrementing the, what is it? No, we are reading the, basically, so the prompt function is an example of interesting Raku functions, which prints a prompt and actually waits for your input and returns this input as a string. And then you convert it to a number, and if it's indeed a number, then you append it to the array and ask for another item, right? After that, you've got the length of this array, and if the width is less, the width is too wide, it's bigger than the array length, it's not, well, we have nothing to do. Otherwise, we're trying to find the minimum. And how do we do that? So we are taking the minimum of this array slice, and the array slice is indexed by this basically range from I to I plus width minus 1, right? And we are repeating this from left, from the first item to the not to the last, but to the last minus w. That's the straightforward solution. So let's run it. Here it is, Raku Ulrich here, Raku chair 1. So we need like 3. What? Yes, this is an incorrect one. So right. So enter the list. I want to enter the same data as we have it there. Challenging 73. And it is 150, 150. Okay, it's not 0. 2. Okay, 0 is here. 3, 7, 6, 4, 8. Right, we have to type end, and here it is. And right, so the first 3 elements, the minimum is 1, the second 3 elements 2, then we have 0, then we have again 0, then we have again 0, and then 3, 4, and the last set is again 4. Right, so it works. Right, let's go next. Next is Roger, number 1. So here it is, the example from the example, I mean the array from the example, and MSW means sliding width is the function which takes the array. And the nice thing of Raku is that you can just pass the array even in the first argument. And yeah, so basically it's exactly the same idea. So we take this slice and we move right from left to right, and after that we just flat again. So flattening, I think flattening is always a bit redundant thing. So Raku Roger Raku ch 1 y2, and I want nothing. Right, so the answers are correct. Going next, I think it will be a really short review, I hope. Yeah, but we've got immediately the huge solution. So we need sliding window at least 3. Then, wow, so slash. So slash is basically, it's kind of is raw. So you can use it as a variable, but without the sigil. What's that? Reasonable frame size. Okay, some frame size. Input. Sample. Where's the sample? Where is the sample? Ah, yeah, so basically here is the sample. Right, so we generate some random array with some random reasonable frame size depending on the window size. Right, and then there are two answers, correct answer and my answer. So calculate every time, calculate sometime. So we are passing two named parameters, number and window size in both cases. And okay, so calculate every time. Right, so that's the solution that I hope we will see in more solutions that were submitted. Basically, the rotor function which takes the pair, and the first element of this pair is the width of the window, and the second item, the second part of the pair is the shift. So if it's negative, that it means, for example, if this is 3 and this is 2, and actually this is 2, right? Well, minus 2. It means that we will just generate. We saw it somewhere in the earlier weeks. There were some examples which were using rotor 3 minus 2. So we will just have the series of 3 elements. Then we map and we apply the minimum function to each of these sets of 3. Well, it's not set. Yeah, it's a sequence. And right, and then we convert to array. The second thing, I don't know why we need it. I think it's too complex to review it here, because we already have the solution which seems to be correct. Let's just run it. Raku Raku chair 1 like 3. Right, so there's, you see, so it should be different each time. Right, it's different. So both answers are exactly the same, and it looks correct, right? So 0 0, then 1 5 7 gives 1, 5 7 6 gives 5, 7 6 3. Right. Okay, so yeah, I think I will skip this, because or just I want to explain. Is there any blog? No, there's no explanation, right? Hey, why did it disappear? Right, okay, so then Mohammed and var, and here is the solution. The solution, there's some default. So you see, so here we just immediately enter the string together with all those commas and spaces, and this is the $A, and S is window, and then we do something and we join it with comma and print. And the function here is right, so you print the list, then you remove all the spaces, then you split by commas. Basically after this you will get the you probably can just use $L instead of $L and square brackets, right? Because it's an array. Right, but nevertheless you can call elements on this container. So this is the scalar container, but it contains an array, right? Right, so we start with minimum sliding window and empty thing. I don't know why we need this, but after that, again, so here's the slice, basically the slice of 3 elements, right? If the size is 3, and we map it. So for each of the elements from this slice, we call this .int method. We convert it to an integer. Why do we need that? Because it's still, each element is still a string, right? Because we took it from the string, then we split it, and it's still strings. And then we take so window is actually, it's another container similar to L, but containing only 3 elements. Well, if the size is 3, and we take the minimum of them and we append this and we move further. And I wonder, why do we need this if we can just use the for loop, right? Right, but nevertheless, let's run this solution. Raku Mohammed Raku Ch1 dot Raku. Right, correct. Okay, going up, and the next is Loren, and here is the solution. The solution is really like compact, and it's using the gather and take pair, a really nice feature of Raku. And for all the elements except the last two, well, if the width is 3, we take the minimum of this slice, and the slice, you see, so it's plus s, right? So but excluding basically -1, as we saw in, I think, in the first solution, there was $I plus s -1, and basically -1 you can always replace it by this hat. A really nice feature that you don't have to forget about. Okay, so let's run it. Yeah, but wait. What are we taking here? Right, so we're only reading the width from the command line. We can't enter the array. That's fine. Raku Loren Raku Ch1, and default behavior is 3. And for this, yeah, is the data set from the example, and it's the same result, right? Okay, going up, Javier. Again, here is the same sample. See, so now we are doing a bit differently, and we start with the element number 2, and right, so this is 2. Basically, this is we start with this 0, then we move 1 element left, and then we move 1 element left. Yeah, that's also a possible thing. So for the last element, when we reach this 8, so we will take 3 elements from right to left, right, and we are collecting the result in the out array. Raku Javier Raku Ch1. Right, the same date, the same input, the same output. Okay, so we are moving really quickly, and here is size of sliding window, list of integers. The interesting thing is how we are going to enter it, right? So just space separated, and we demand there's at least 1 item in this array, and then you understand everything here, I believe, right? So the only thing, the only difference comparing to the previous solutions is just basically how you call min. Either you use it like this, or as a function, or the function called within the map. But here we just clearly take the set of 3 elements. Basically we take this window and we apply minimum to this, and that's it. All right, so Raku Jaldar Raku Ch1. So we need something, right? So we need 3, and I wonder if I can just take something like I want these elements, but I cannot do that because I need to do it like this. Right, voila. So yeah, we've got the same result. Right, so yeah, it's not a surprise that it works. The task actually is really simple. Call and crane the solution, and right. So there's the input array if. Oops. Interesting. Wow. So we are reading the array from the command line, and there's no default value here, but default is here only if the length of this array is 0. If the array is empty, so it means if we didn't enter anything, right? Really interesting. And for the width it's just, so basically we can just use the same input as for the previous program. After that, again, so we're using rotor. So basically, so far we have two different types of solutions. So one using rotor and one using just direct slice of the array. And then we map all those things of 3 elements we map and we apply minimum function, and that's it. So all the rest is just printing the output in the correct format. Raku calling Cray Raku chair 1, and all the things actually are default already there. So input is this one, window size 3. Here is the list of all those windows, and here's the result, which is exactly the same as the result in the correct solution. Right, at Nasus. Okay, so right, even here we have a really compact solution, which means that Raku is really good for such things. And where do we start? So natural, I believe it's subset, right? Subset of unsigned integers, and yeah, so this one is really long. So we see, so let's look at this. So yeah, by the way, I didn't mention, but notice this star for the slopy parameter, which just eats all the elements when you enter it like this. It will all these elements will appear in the same container, in the same array. So we have the array at least with one element, and it should be bigger than the width. And is there any limitation for the widths, by the way? I don't see so, right? And all the elements are integers, right? So this is also a really nice thing. So you can just put all, there's no need to organize any loop or map or whatever. After that, what we are doing is minima, plural Latin word, and we're pushing, right, minimum of this slice for all the elements, right? We saw this. Okay, okay, so let's run it. Raku Athanasius Raku chair 1. And what do we need? We need S is 3 and all these like this, right? If I'm correct. I'm not correct, but why? Right. Okay, so the result is correct. Good. Going up, and here is the solution by Arne, and here it is. Woohoo! That's a long thing. Okay, so what's that? This is all the same. I mean, all the same. Like again, we have this start to just consume all the integers from the input from the command line. Right. So here we check if all of these are integers. So you see, so smart match, and you see, so basically, if you look here. Here the solution is, you see, so smart match again, so just call dot all and that's it. Or alternatively, you can do it like this, use a subroutine instead of method. It's exactly the same in this case. And what we're doing next, so we're taking the indices from the first element to the element, like 3 positions to the end. We map. And where's this one, right? So yeah, so if we want to debug information, we don't want this. And so again, so we take these indices, we map, and the map body is shorter here, which is good. And inside it, it's exactly the same thing. So again, the range for the current position, and right, -1. So yeah, we could remove this -1 and put the hat here, and that's it, right? So that's the simple task for this Raku challenge. Raku Arne Raku chair 1. So what we need 3, and we need data, and the result is the same, right? Simon Proctor Raku 1. Here is the solution. The solutions are right. So directly, and I think I first saw this use of rotor in Simon's solution somewhere earlier. So we just create the series of 3 elements, and then we apply min method to each of them, and that's it. and the input restrictions are quite long here. So yeah, so we should have at least size elements, and all of them are ints in this star here, right? So yeah, so when you look at this, it looks long, but actually it's just because the numbers, the name of the variable is quite long, and it's repeated 3 times here. Right, Raku, Simon, Proctor, Raku, 1, and what do we need? We need minus size is 3, and all the rest is the same. Here it is. Right. Node, Raku number 1. Yeah, gather and take. Gather for the indices. And right, we take the minimum by right. So yeah, so that's the second type of the solution, where we use ranges rather than the rotor method. And instead of, yeah, so basically like the subset of the method is just either you use gather or you use push to collect the results. Right, Raku node, Raku 1. So we need like nothing, right? Right. Okay. Marcusholtzer, and here is, yeah, very concise and compact solution using the rotor on the map, and I like this. Raku, Marcusholtzer, Raku 1. Right, Mark Anderson, and yep. So yeah, it's the same. The only thing I don't understand why we don't need like dot list here. Probably just to make some better output. So we need S and A. Raku, Mark Anderson, Raku 1, and I can copy these. Yeah, right. Okay, and the unit submain is really a nice feature. It's just, yeah, just simplifies everything for these short programs. Luca Ferrari, Raku number 1. So here's the input thing. Yeah, so and here we just, that's something new. That's something new. That's the use of reduction operator with a function. Like when you compute factorial, you can use star here inside the square brackets, but you can also use any function, either built-in or your own function, and it will be just apply in between the elements. So there are 3 elements here. You see, again, there's the character. Yeah, actually, if you have the character, but you still don't need parentheses, right? I want to say that if you can gain a couple of characters if you will use -1, but actually not, right? Because you don't need these parentheses. Right. Okay, let's run it. And actually there's the example of how to run it, but Raku, Luca Ferrari, Raku 1, and I think I have it in buffer. Right. Yes, and going to the next solution, Jason gives us this: gather, take. So all the elements, like all the elements combine in different combinations. So here we loop over the indices and we take the range, and we use this -1, right? So Raku. So what do we need? To input JSON. Raku 1, nothing, right? Right. Jan. So there's the test, the desired input, desired output, and so something new. And then, right, let's look at this. So, and then is kind of the element of width, like width. So it typicalizes, if I'm correct, right? So we've got this A, and we apply it here. Rotor, right? So we're using rotor, and then map. Well, that's it. See, so just a feature, a built-in feature of Raku, and when you look at this, there's an impression of some kind of other programming languages, right? It's not a typical Polish language. But nevertheless, so basically we just apply this method to the result of the previously computed thing. Right, and I wonder where's the result. The result is just the last computed. Basically, this mean sliding window gives you the array in the output, right? Right. Let's run this solution. Raku war. What was that? Right. Raku 1. So the test module is used there. So yeah, really. What do we? And otherwise, why do we need this? Right. Okay. Right. Ben, and okay, so there are 2 solutions left. So here is the solution again. So it's like plus array. It's so you can use you have to look at the documentation. What's the difference between plus and star? Is it the same as in regular expression? Because, well, I expect it to be the same, but I'm not sure. I expect it to be the same because Raku tells us that it's really using the same items in different places and they mean the same, but who knows? Right, so they all should be defined integers, and there's s, and there's some limitation for this s. After that, we just take the array of indices and use I think we already saw this maybe even in Ben's solution somewhere earlier. Basically, instead of taking the range, you can just take, you can skip and you can take the head, or vice versa, right? Head and skip some elements. No, head and take the tail, right? So basically just some skip and then head, and take the minimum of those, and we do that for all of these indices. Interesting approach, and let's run it. So we need to enter, so Raku Ben Raku chair 1, and what do we need? So we need first we need the array, and after that you see, so basically after that, and you see this exclamation mark, so it is really expected there in the command line. So you see, so you can consume the array first, but then basically, maybe actually this plus, I have to look at the documentation too. I think dux Raku plus, the only thing I think that you will not, you have to search it, right? But it's class signature. Like, this can be achieved by using Slurpee with a plus instead of $. Plus Slavic convention. It will augment by the broken element ways. This can be achieved by using Slurpee with plus instead of. Right. Okay, so that's your homework, and nevertheless, so we need an array first, and then we need this 3, and it's completely incorrect. I mean, like this, right? Ooh, so it's required, but it should be on the first place. That's the thing I find a bit incorrect. I mean, incorrect in design, because it's, well, actually, it's a named parameter, but why you cannot read it if it's in the end? And okay, never mind. The result is correct, and finally, the solution, my solution, and here is right. So again, I'm using rotor, but you see, so I compacted it a bit, so I'm using 4. So so we see, so map and 4 are the other branch. Map, you can map, or you can just use a 4, and you will topicalize this, and if it's a topic, you can call this dot method, and basically you receive this. So effectively, for the input data, it gives you 3 and -2, and the result is a sequence of lists. Right, so Raku ash Raku chair 1, voila. So I printed it not like the other solutions, but nevertheless the numbers are correct. And that was it. So it was really a simple task. So yeah, I saw that Mohammed promised that number 75 will be really difficult, but let's see. So nevertheless, so it's all for this minimum sliding window. There's another task, smallest neighbor. I don't know how difficult the solutions are yet. So yeah, stay tuned. See you next time.